The little box doesn't even have to be there. Alright, so this is how our mini lesson is going to work. So we are new to this cup thing. Alright, but basically you're using the cups to identify your need. So if you guys all have green, that means you're good, you don't need my help. So when I'm over here teaching, you don't call my name. You see what I mean? Because I'm over here teaching them and I'm doing a lesson. So instead of being like, hey, Miss Johnson, blah, 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 you just tell me by your cups. I'll kind of randomly look around, make sure everybody's still on green. Alright, so that's how you signify your need. And then I'll address you whenever I have time. Alright? So green means you're good to go, you don't need anything. Alright, right below that one is yellow. That means, hey, just come help me when you get a chance. It's not like a dire need. Alright? Red is I'm stuck and I can't move until, like I can't move on to the next question or do with the next question. So I really need your help as soon as possible. Or if you have a computer issue and you need some help with it. Blue means water or bathroom. Alright, so don't even ask me to go to the bathroom, just put your blue cup up. When I see your blue cup up, I'll be like, hey, let's go, and then we'll be good. Alright, make sure you take your agenda. So you can get out of your seat to sharpen your pencil, but that's really the only thing that you need to get up for. Alright, and adhere to your noise level. So this is what we're going to be doing. You can take your notes and your stuff with you wherever we go. Alright, so Braden, Colton, Alejandro, and Nick, you guys are going to be on your technology. This is what you need. These are your supplies. Alright, remember all our supplies have shifted because of our scale model projects. They're all back there now. Alright, so you need a computer, headphones, calculator, dry erase board so that you can do your work. Alright, this is what you'll be doing though, Colton. You have 2 virtual nerd videos to watch. Alright, on the Pythagorean theorem, Pythagorean triples, and then you can complete your math Excel assignment. Alright, it's all assigned, it's all there. Okay? Christian, Jade, and Cartel Horace, you just meet me here with a pencil. And you also need a calculator there in the back. Partners, so Clave, you'll be with Emily. Kayla, you'll be with Sarah. Ashton, you're going to be with Freddie. Alright, and you guys need your guided lesson, which is right up here. Alright, calculator and pencil. So does everybody know where to find everything?
Yeah.
Alright, let's go. No, just pass these out. He's sitting there. I forgot he's going to be here. Alright, so if you have a partner, make sure you grab your guided lesson. That's what you'll be working on. Here you go. Just move it so that I steal. Or it's easy work. Are you sure these aren't yours? Yours over there? Whose notes did I take? I'll look right here. Oh, duh, thanks. Sorry, I'm having a moment. Alright, so are there any questions about what your expectations are from the individual technology people? Alejandro, you're good. Colton, you're good. Braden, you're getting what you need. Nick is in the office. Alright. And then we have Christian, Jade, Cartel, Horace with me, so we're going to start in a second. Alright, and then Claudia, Emily, you're good. Kayla, Sarah, Ashton, and Freddie. start with this one. I'm gonna go check mine. We haven't been just sitting here and so we start on this one and we're gonna do the rest of these together. All right, you guys can talk and work with each other.
Yeah.
Technology. Remember, you're solo. And you should have headphones on. Alright, what's up? That before, okay, so you're thinking about simplifying. Alright, the first thing that Jaden did is he wrote down he plugged in X for 100, he plugged it in. Alright, so that's the correct first step, right? So what you're confused about is you're thinking how many times it goes into there, but what is he thinking about? He's thinking about long division. It kind of looks like long division, doesn't it? But what is this 3 doing with this grapple? It's on the outside, so what is it doing? Combining, what do you mean? You multiply it, very good. So, he said whenever you square root this number, when it comes out, that's what you multiply by. Perfect. Alright, so square root of 100 is 10, and then you times it by 3, and you get 30. Alright, I'm gonna grab a dry erase board so Horace can see. So far we come. Alright, so then the next one, which is going to the right of it. So Horace, do you have any questions about that one? Why it's 30? Good? Alright, cool. Okay, so this next one, it reminds me of you guys, so if you already put it in the calculator, no Horace, don't cheat. Alright, so, using a calculator will give you the answer, right? By the way, what's an integer? Well, decimals and fractions are rational numbers. So integers, where do we see those? On a number line. Negatives, good. So in 6th grade, starting in 6th grade, you guys start doing like negatives and positives, and you have to add them the whole time. Yeah. Alright, so this is an integer, 40, it's an integer. And they want to know what 2 integers would be between once we square root it. Alright, so what's difficult about 40? Why did you have to use a calculator to find it? It's not a perfect square root, it can give you a decimal. What kind of decimal? Irrational, right? What does irrational mean? It's crazy. It goes on forever. And there's no pattern. It just keeps going on forever. Alright, so square root of 40, this is how I would figure it out. What's a perfect square that's near 40? No. 36. What gives you 36? Right? Alright, so 6 times 6 gives you 36. What's, 40 is bigger than that, right? So then what's 7 times 7? 49. So since 40 is in between 36 and 49, when I square root it, I should get something in between 6 and 7. So square root 40 in your calculator.
It's 6.3.
Is that in between 6 and 7? So you see how you can use your perfect squares to kind of help you guesstimate where it is? And that's what they want you to do. Alright, so your answer would be in between 6, and 7. And we used what to help us? Our what? Our knowledge of perfect squares, which we can square root. Good. Alright, so what? Alright, how do you know? Alright, so it could be. Well, look at the thing at the bottom. Look at the thing at the bottom. It says use process of elimination and what you know about triangles to figure out the answer of.
I thought these two things.
They could be, we don't know. Well, how would we know for sure if they were equal? What would have to be there? So remember earlier when we were talking about the side lengths? What was present if they were equal? They didn't have numbers. Oh, look at your notes. The little line segments, right? Do they have the line segments showing that they're equal? So we don't know if they're equal. Alright, but doesn't mean it can't be 8. It could be 8. Alright, but what answer choices could it not be? Why not? It just looks funny. Alright, what do we know about the hypotenuse? It has to be what? It's 17, and it has to, it's what part? It's the it's the longest part, right? So, then why can't it be 19? Yeah, so what other ones can you eliminate? Alright, let's cross those out. Alright, so you could do 2 things. You could plug in these answers to see which one works. Alright, you want to do that? Alright, so let's do, so write down your, whatever I write on here, you're writing on your paper. Alright, so he's writing down the formula. That's the first thing we should do. Alright. I already hear he's plugging stuff in. So you plugged in 8 squared. What did you plug in for p?
17.
Alright, what did he do? What did he do wrong?
Oh, no, it's X squared.
Alright, but what if we... So, before, you guys said you wanted to use the answer choices to plug them in. So what's our first answer choice we plug in? 8. So shouldn't 8 go for B? If we're testing to see if it works or not? What did work do first? You put 17 in for a what? It's longer. It should go in for who? Yeah. The hypotenuse. So I'm signifying that this one is the one we're plugging in just to make sure it works. Alright, so it's 17 squared. What have we done that one?
Oh, yeah.
Oh, yeah. I think we did something similar to that earlier. Alright, so then this was 8 squared. 64 plus 64. Alright, so of course, what's 64 plus 64?
64 plus 64.
Yeah, well, what's 60 plus 60? Good, so what's 4 plus 4? So 128, good. Alright, so what does that tell us? So what's the answer? Okay.
You're right, and I see that as very.
Oh, you did? Because they do look like they could be. One thing in geometry you'll learn is you can't ever assume, unless they tell you that those two are equal with tick marks or something, you can't assume that they're like automatically equal. Alright. Okay, so it says explain the difference between these 2 answers. Oh, this is tricky. But remember, think back to algebra. So first of all, what's the square root of 100? What would you do? Okay. Alright. But the next one, what do you do to solve it? Because it's a square root. You square root it. So put your little square root sign on both sides. When you square root both sides of the equation, what goes with your answer? Think back to when we like the quadratic formula,
Oh, plus the
the plus or minus sign. So it's plus or minus 10. So do you guys see the difference? If it's just a square root of a perfect square, it just equals that number. But if it's an equation, we always have to include the plus or minus sign there. I know, just alright, so when you guys are ready, flip to it. Alright, so don't use rulers for this. All I want you to do is see where it says what are the lengths of the shorter sides of the triangle, what is the length of the longer side of the triangle. Alright, what you should focus on is just the numbers that they give you. Alright, I'm going to see what your need is, and you guys answer those first two questions. Okay, so originally the case of pyramid shows the right in the triangle dimensions, how far is it from the base? So, if you look, at the corner of the base, I'm thinking what you're talking about is this, you're trying to find what this is. Does that make sense? You're trying to find what this side is. 112. So you're basically like forgetting about this part of the, and just using this right triangle to find the missing hypothesis. They just applied it to pyramids. Good use of your toes. Alright, what was the lengths of the shorter sides? 5 and 7. Alright, what was the length of the longest side? 10. So this kind of looks like that picture from your notes with all the different like squares, right? So what are the areas of the squares off the short sides? So, wait a second. What would be, this one right here? This red one that I just made? What's the area of that? Because you did base times height, right? So what's the area of the other one? 49.
So you had those.
So it'd be 25 and 49. And we add
Oh,
up.
that's what, I thought it was the
Aren't you guys, didn't you just pretty much find a squared plus b squared? Does that make sense? Alright, what's the sum of those two areas? That's also what you got adding from. Sum is adding. So question, what'd you get? 74. Alright, what's the area of the biggest triangle? 100. Between the sum of the areas of the shorter side and the area of the longest side. So if you're explaining the relationship, what was the area of the shorter sides together? Which together was 74. Okay, and the area off the longest side was bigger than theirs, right? So let's say the area of the smaller triangles, or smaller squares, excuse me, were what? Smaller than the area of the largest square. How much bigger is the area of the largest one than the area of,
I mean,
16, right? No,
No.
more than
oh yeah,
that.
actually,
26, there you go. 26. So 26 is their difference. I just added that to the end. So 26 is their difference. Alright, so let's down here where we have space, I want you to write a squared plus b squared equals c squared. So we're gonna do what we just did, but apply it to the pyramid. You can just write it, let's start. Wherever you have room. So what was our A? 5 squared, which was what?
25.
Alright, so just go ahead and write 25. And then Christian, what was our B squared? 49. Alright, and then our C squared was 100. 74 is whenever we added the two sides. So 74 equals 100. Do you guys see how he said that? So it was smaller than that. So what does that tell us about the back right here? You can't do it. So what did we learn about that? It didn't work. What does it tell us about the triangle, or about this triangle?
Oh, it's not right.
It's not a right triangle. So this right here, if you guys kind of look, you can tell it's not a right triangle. Do you see what I mean? Yeah, well, the right angle has to be across from the hypotenuse, right? And isn't this the hypotenuse? So the right angle should be right here, but it's not. What would you describe that angle as? He's obtuse, isn't he? He's a bigger than 90. So this is an obtuse triangle. So you guys are kind of learning ahead of what you already learned. So the sum of these was smaller than the longest, right? So anytime that happens, if this is smaller than that, it's always an obtuse triangle. But what do you think happens if this is bigger? It's a cube, which is kind of backwards. You can't do it the other way around. But we just tried it, and it's obviously obtuse, right? Okay, so let's flip on the left. Alright, we're just gonna test these guys. That's all we're doing is, for this one too. So we might get a whole different type of answer too. Alright, so I want you guys to fill out the first sheet. I'm gonna check on the other green just to make sure they're doing okay. Alright. Oh, look at you. So thoughtful. Okay, I'm just looking at the list of your green. Is everything good? Okay, cool. It's kind of fun, isn't it? Just plug in. It's kind of easy. Are you guys doing good? Alright, your work looks great. Using the formula perfectly. You guys still good? Yeah. Good with those? So, you're looking for a leg. So I told you B allocated process 6, C is 6.1, and you don't know A. So B is 36 and 6.1 squared, check this out. Is that and then minus 36. So I mean, that's definitely mathematically the answer. So 1.1 squared plus 6 squared, which is 36, equals that. So you did it right. But it does seem like unreasonable. It should be closer to 6, I would think. But you're right. You guys over the news? Now, I think I'll do this as a topic of discuss. You doing your videos? Yeah, thanks. Well, let's go answer the other questions first. You did? Alright, tell me what you get.
3, 4, 5, 6, 7, 9, 25, 25.
So what are the lengths of the legs of the right triangle? So you said what, 3 and 4? Christian, you get the same thing? Alright, and additionally, you get the hypotenuse. 5, good. Alright, so the area of the squares off the legs, what did you get? Perfect. Wait, 12 and 16? You know what you did? You just replaced the lower.
I got 2 C's in
Maybe 16 and 9. Just look. This one is 3 times 3, and then 4 times 4. And you accidentally multiplied those.
Oh.
So this one, 1, 2, 3, 4, 5, 6, 7, 8, 9. That area is 9. So it'd be 9 and 16. Does that make sense? I think you saw the 3 and the 4 and the 25. 12 on it. So you following this, Judy? Oh, it's okay. Alright, so then what did you get when you added them? 25.
And the half two is 25.
Okay. And you remember how we talked when we did our geometric squares, areas of space inside? If you count all of these squares inside of there, it's 25. Alright, so if we relate this to diagrams, is everybody good?
They're both equal.
Good equal? Because look, a squared plus b squared equals c squared. So you guys told me 2 legs were 3 and 4, and the hypotenuse was 5. So we got 9 plus 16 is 25. And this equals 25, the sum of them. So it worked, right? So what does it tell you about this triangle?
And it's a right.
It's a right triangle. And they even put the little box right there. So explain the relationship between the sum of the areas off of the leg and area of the opposite hypotenuse. They are what?
And the hypotenuse would be.
They're equal. Perfect. I think course is going to be really good geometry. Alright, do you think all right triangles will have lengths that are integers? All right triangles are integers. Yeah, and integers
Are negative.
are negative.
And all right.
Yeah, so you can't have negative like lengths, right? Okay. You already did it. Perfect. And then, do you notice how it equaled where the other one didn't? So this one would be considered what kind of triangle? A proper right triangle.
Same thing.
Okay, we're gonna test one more. Let's skip to the last one. We're gonna skip to the last one. Alright, so 5 and 12. She does. Look at you helping me. Which one? Take your initiative. She's on you for everything. It's like a chain reaction. Are you guys done? Awesome. Alright. So go ahead and finish this last one. You guys are probably already done. You're like way faster than I am. So 25. And 1.4. So we did 5 and 12. But it says right here in the length of hypotenuse. But this is the area of the squares. So you take this to square, you take this to square. It's equal, so what kind of? Okay. So that's all you need to do. Alright, so listen, the bell's gonna ring in probably 10 minutes. Alright, so what we're gonna do is we're gonna start transitioning. If you have partner work for me, you need to turn it into the school. Alright? If you have a computer, you need to start putting stuff away. Calculators, everything needs to be put away. What should you do with your notes?
Put it in your bag.
Keep them, put them in your